All right, lecture 2 of chapter 1. Measurements provide the information that is the basis for most of the hypotheses, what we measure, how we measure, and how we use those measurements. And that's going to be important. That's just critical to chemistry, and that's going to be important for you in terms of how you learn the material. The 3 things I always think about when we do this: process, units, sig figs, over and over again. Okay, so when you have to do problems and show work, you want to think process. I will look at the process, I will look at the units, I will look at the sig figs. Okay, typically if those, you lose points. I am not the big partial credit person either. Well, I was close. Yeah, but close, you still lost the game, right? Close. Man, that shot was close. Yeah, sure was. Final result. Does everyone follow me? Okay, just how it works for me. Does everyone follow us? So think about your process, and we're going to be showing you the process that works best when doing chemistry math, the units, and the sig figs answer. So here the size of the numbers going to matter, the units will matter, and some indication of accuracy and precision, and that's why we get into sig figs, rounding, etc. Okay, without units, a number can be meaningless. If you show your work and there are no units, and there should be units associated, it was nice, it was beautiful, you got the final output, but you're going to lose points because you didn't show the units. So everyone follows? If you give me an answer, you don't show me how you got it, great, you got the answer. And some of these answers are not going to be that challenging, by the way. Most of them you can do in your head, okay? So everyone follows. So it's not that I'm going to give you these tricky numbers that you can't do. Most of them you can calculate in your head and say, oh, that's going to be 22. 22 what? And how did I get to the 22? Does everyone follow us? That's what we're interested in. That's what we're trying to teach you. Okay? There is a system called the SI system, System International, which is a system that's used for scientists around the world. However, we also use the metric system. The English, US English system is rarely used for doing any type of scientific, really deep scientific work. Okay? If you're a dietitian, etc., it's used a lot, and things of that nature. Nutrition is used a lot. But in science, basic science, we don't use it. The System International is a system. However, you will be seeing the metric system because that is a system that we like a lot in here, okay? In science. We still use it, very popular. These next slides are simply here for memorization. You won't have to memorize them, but because you'll get used to it. But some you will want to know. You definitely want to know the one that's the bottom bracket here. These are the types of things that ACS likes to know when it asks you a question like what's the standard units, etc., etc. These you'll want to have fixed in your head. Okay. There will be on the first exam or so, I will ask you some of these, but after that I will expect you to simply know them. Okay. And so you'll get used to these. You can memorize them, but there's no magic for this. You memorize them. Here, these are a lot of units you'll be seeing, kilo, mega, etc. You will see these types of units, expect you to just kind of generally know them as well. So this is basically memorization stuff. And then we have all of these. This is simply memorization. Now, the good news for you in terms of memorizing them is I tend to give you all the conversion factors you need, and I give you these on the exams. But you'll have to know what kilo means, right? You get it? So you can use it. Does everyone follow us? So if we have to convert something on the exams, I usually have the conversion factors on there. Okay? So I'll have, 1 kilo equals 1,000 grams, things like that. Okay? I'll give you all the conversion factors. And if they're not there, you ask me, I'll usually tell you what they are. Our goal is to learn how to do the math processes, how to apply the proper units, how to the proper accuracy and precision through sig figs. So everyone follow us. That's our goal as we teach this. Okay? There are some you will know, and again, I'll just expect you to know them. Okay? So everyone follow me. I am not telling you to sit and memorize all 3 of these charts. It's not what I'm asking you to do. Some of you are familiar with, for the most part, I'll give them to you. You ask me what's a kilo, I'll tell you it's 10 to the 3. Does everyone follow me? Okay, if you know how to use it, I'm happy. Okay, for some people, memorizing a lot of stuff is just challenging. It's just the way it is. Okay, but I do expect you to know how to use it. Does everyone follow us? And some of the basic ones I do expect you to know. Okay, and you'll know what they are because we'll use them a lot. Okay, so the common ones I expect you to know. Clear enough? All right, clear on the expectation. So I'm not asking you to sit down and memorize all these. Okay. Somewhere in old history is a guy named Shaquille O'Neal. You guys will probably have to Google him or something to look it up and figure out who the heck who, because you think he's the guy that just this in the insurance commercials, the general. He's okay. He's okay. He's pretty famous old basketball player. All right. It's interesting if you look at his numbers. The average field goal percentage, means just general shooting the basketball in the NBA, is about 40%. So you're shooting 40% in the NBA. That's it. The elite people are 45 and above. They're just good. They're better, okay, than that. Free throw is 80%. Okay, these are from the same terrible sources that you look up. All right, so these are the numbers. Interesting enough, Shaquille O'Neal came to field goal percentage. He was just a beast. 58% is pretty darn good. You get in the ball, he's going to get scores for you. But if you put him on the free throw line, it was absolutely horrible. Horrible. I mean, just horrible. Okay? All right? And now comparing them to the other elite players, Kobe and Larry Bird, I mean, field goal percentage, 50%. He was better than they were from the field because no one could just stop this guy, right? Okay? But free throws, they're in the 84s and he's there. But the interesting thing about his shooting, he shot the exact same horrible way every time. Every time. He missed the same way, shot the same way, ball bounced off the rim the same way. Guys, when he went to the line, guys on one side just go to sleep. Well, we know the ball's going to go over here, and he's going. Yeah, it's like Shaq's on the line. Okay, he's going to shoot the same horrible way. Okay, we're showing you examples here of accuracy and precision. He was very precise, but his accuracy was so terrible that's why they kept fouling and putting him on the line. That's what you need to understand, the difference and the similarity and the usefulness of accuracy and precision. You can be very precise, but you keep missing the target and no one's going to hire you to work in this shop. Does everyone follow? Okay? Even McDonald's won't hire you because you keep putting too much of the special sauce, lettuce, cheese on the Big Mac. You get it? They like for you to be precise and as often as possible accurate. So here we are. When we measure precision, it yields similar results. And that was Shaq, similar results over and over again. Same horrible, similar results over and over again. But it was in the same spot every time. A measure of accuracy yields the result that is closer to the true and accepted value. It's what you're after. Okay? And you will be asked to regurgitate this type of information on the exams. Accurate and precise is the first one. It hit the bullseye and it's precise. Now, it doesn't have to be perfect as long as it's somewhere in that circle. You get it? So your numbers won't be perfect numbers. You're not after perfect when we talk about accuracy, but it is hitting the general target. You get it? In this particular case, it hit the general target, and I should probably make a fourth chart. I don't think I'll do that. And it was pretty darn precise in that target. You get it? Okay? As long as it hit anywhere inside the center ring, you're going to call it accurate. Does everyone follow us? But this person was really accurate and precise with their targets. Precise and not accurate, it's precise. They're hitting the same general area, close enough. Okay? But they didn't hit inside the bullseye. The other one is not accurate and not precise, and you can get something that's just really horrible. Okay? You will have to do this. You'll be doing this by evaluating data, though. You'll be given data, and you'll look at it, and you'll answer the question whether it's accurate and precise, or precise and accurate, et cetera, et cetera. Okay? You're not looking for perfect data. Okay? If someone let's say that the target is 60. If someone hits a 59, a 58, and 57, would you say that's close enough to accuracy? Yeah, because a number of 60 and you're only off by 3, you say that's pretty darn good. As everyone follows, it's all general to where you are. But if you're shooting for 60 and you hit 50, 40, and 30, you say, not hiring. Does everyone follow us? Not putting them on the free throw line. Okay? Does everyone follow it? That's a concept you'll want to catch there. And you'll have to practice that and be familiar with it. That will follow you through to the ACS2. They like to talk about this. So here we could play with it if we wanted to. What do you say about the first target here? Is that accurate for the first target here? I know it's 8:30. I get it too. Okay? I left my coffee in my office too. Bad move. All right, so this is what? What do we say about this one? Anybody? So you say this is accurate? No? Precision? Yeah, pretty precise. What about this one? Accurate and precise? And here, what do you say here? Not accurate. You get it? But you'll be given data. You won't be given a target, bullseye target. Okay, I'll give you data. You look at the data, you eval it. Okay? Again, chapter 1. With chapter 1, we go through a lot of definitions and getting used to how we talk and communicate. You'll find that to be the case when you take the online homework and the extra credit. Some of it will be simply you getting used to the way I'm presenting it. We'll deal with that. Does everyone follow? No panics on that. It's the way we communicate with each other. We'll get used to it. Does everyone follow us? So some of your misses won't be because you don't understand it, just the way it was worded. And you'll go, oh, is that what it means? You'll have to get used to that. Does everyone follow us? All right, let's move on. The next thing we're going to talk about here is rounding rules. Now, the rounding rules across the world vary. So we're going to agree upon what rounding rules we're going to use here, okay, to help us get through our process. If you go into other areas, you'll want to ask them, what rules are you using or what principles are you using for rounding? I'm only talking rounding. Does everyone follow us? Okay, because some disciplines have rounding slightly different for various reasons. Okay, all right. Okay, and that's pretty important. How you round is important. For example, if you're working for NASA and you want the astronauts to come back through the atmosphere, one set of round that could bring you through the atmosphere and you could get in at the wrong angle and you burn. Okay. The other set of round that could bring you into the atmosphere, you hit the atmosphere, you bounce off and you don't get in. The other set of round that could bring you in exactly like you need to, every perfect angle, just right for the conditions. Do you follow me? So you have to be aware that the round is a pretty important principle when it comes to rounding. Okay? Are we good there? That's what you want to think about. So these are the rules we're going to use. All right? And I do understand that some of you had AP and Honors Chem and they had some form of rounding there. Don't use it. Use this one because the apps will be set according to this standard. Get it? All right, so you'll want to be aware of that. So if the digit to be dropped immediately is less than 5, leave it. If the digit is more than 5, increase it. Let's just show you what we're talking about here. Don't try to memorize the rules. Learn how to do it. You got it? You can memorize them if you wish. The next rules you'll have to memorize. Watch this. All right, in this particular case, this is the number we have, and we want to round it to 1 decimal place. So this is where we want to round to. We look at this number. This is a round up. Does everyone agree? Does everyone see that? This 9 is greater than 5, so we round this number up to 5. Does everyone get that? These are the rules we're going to agree upon and use. Here, we want to round to here. This is a 9, so we'll do it again, round up. So that's going to go to a 7. Look like I did all these with this. I didn't even realize it till now. So this is a 9. I must have this fetish with 9. Gee whiz. So here's a 5. This is a 9. This rounds up. Does everyone see it? We're rounding here. This is a 3. This is a 7. We round up. Does everyone get it? Okay. Those are the rules we'll be using. Make sure you take a look at them so you can get used to this set of rules for rounding, because the apps will be set to that. Okay. Good so far. Okay. The next part is significant figures. There are textbooks and other publications with sig fig rules ranging anywhere from 5 to 7 to 12 to more. You may use them if you wish. I only use my rework of those, and it's something I presented the ACS. That boils it down to only 2 rules. It is mathematically sound, does not violate any mathematical principles, and it never misses in terms of the sig fig counting. So everyone follow us. Okay? Follow? Occasionally I've had colleagues who tried to refute it, and they can't. It's still sound. So I'm going to teach it with my 2 rules. Does everyone follow me? If you choose to memorize the others, I am perfectly okay with that. At the end of the day, the key is, can you count sig figs? So everyone follow what we're saying. When I talk to you, however, I will be talking to you from only my set of rules. Make a note of the things that I will never ask you. I will never ask you which of these zeros are significant. They may ask it on ACS and standardized exams. For me, it's irrelevant. Who gives a rip? If the number is in there, it's significant. Does everyone follow us? If you're using the number, it's significant. That's the answer. So I'll never ask you, is this a significant zero? Is this a significant zero? Most other rules are centered around zeros. My rules are not. Does everyone follow us? So you'll never hear me overemphasize the zeros. I just want to make you aware of that for those who've had AP and honors chem and learned sig figs another way. I'm okay with that. If you're good at it, you're just good at it. Got it? Not asking you to change. So here are the rules. My rules involve the decimal. If the number, I think it's a typo in one of these 2. Oh, I think I must have corrected it then. Okay. If the number has a decimal, ignore, strike all zeros to the left, the leading in front of it. All remaining digits counted as significant, even if they're zeros. So everyone follow. We'll show you how it works. So you check first, ask yourself, is there a decimal? If there is, then ignore or strike the zeros to the left. Be aware now, and you'll see it come and see the warning. Ignoring or striking does not mean changing the place value. The zeros are still there. You're only striking it, drawing a line through it so you can count. Does everyone follow? This is for counting sig figs. It does not change place value. Get it? You don't strike zero and say, well, that number becomes this. No, it's still the exact same number. You're just counting how many sig figs you're going to use. Does everyone follow? This is not rounding. You round and then you count. Okay? Ready? If there's no decimal, all right, ignore or strike the zeros on the right side. Okay, these are called lagging. So if you read it somewhere else. All remaining digits are counted as significant, even if it's a zero. All right? Now let's use it. You will hear me when I talk about it, and I think the next slide will show it. I call left-handed and right-handed. You hear that term. Right side, left side. It's just speed. That's why I say it that way. But these are only 2 rules. When you ask me to help you, that's the question I'm going to ask you again. Let's do the rule. Does everyone follow me? Now, some of you are going to mix my rules with some other rules. You will probably blow some of your problems that way. Okay? If you add to the rule, it'll probably hurt you. Follow? So you have to decide which set of rules you're going to follow. You get it? All right? I think I may have a note there. Do not mix Revis rules with others. It will hurt you. Get it? Okay? So it's not one of the rules. Well, if I mix this with this makes it even better. If you find a better rule than these 2, then I really would like to hear about them. I've been searching. Haven't found them yet. You get it? They're short, they're sweet, and they're mathematically sound. That's important. Does everyone follow me? It doesn't violate any rules of math. It's not a trick. Does everyone follow us? Okay? Let's play with it. So get ready to talk to me, folks. Ready? All right, everybody's awake. Get ready to talk. All right, the first one here. Number 1, does it have a decimal? No. Which side do I ignore? The right side. You agree? So I just draw this line here so I can ignore it. Are the zeros still there? I'm just what? Drawing it for visual purposes only. How many sig figs? 1. Does everyone see what I just did? Second one, is there a decimal? Which side do I strike? Are there any zeros out here? So what do? Count. 1, 2, 3, 4. Does everyone see why it's 4? Does everyone see that? Once you strike, you count. Don't add to it. Well, what about those zeros? Chill on the zeros. Just count what's left, including the zeros. Get it? All right? I will never ask you which zeros are significant. No one in any laboratory in the world ever asked that question. They ask you to report to the proper sig figs. That's it. Okay? Ready? Number 3. Is there a decimal? Which side do I strike? Which side? Left? You agree? Right? Okay, right then. Right side. Are there any zeros to strike? Come on, brave souls. Any zeros to strike? How many sig figs? What do I do with these zeros? Nothing. That's the key. Don't focus so hard on the zeros and you'll be fine. Does everyone follow us? Okay, you only look left or right and that's it with these rules. Does everyone follow? But the rules in OpenStack, I think they're 7 to 8 or 9. You can memorize them and do it that way too. I'm okay with that. I only teach it this way. Number 4, let's move along. Left or right? Do I strike here? Strike here. Right? Over here? How many sig figs? 2. You see it? Here? Left or right? Right? Anything to strike? So what do? Just count them, right? 5 there. Here? Which way do I strike? Sig figs? 3. Is the number the same? Yes. You don't change. The number is still 0.00137. The number does not change. It is still 0.011. You get it? If I round this to 2 sig figs, then it's going to be 0.0014. I can't destroy place value. Does everyone get it? The number is the same. I'm just ignoring it. This one here, strike here, right? It's a decimal. 3 sig figs here. 4. You agree? Just walking through it so we can see it because you will be here. This will work the rest of the semester. You'll miss a point every time you miss these sig figs on the exams. Does everyone follow? You get 30 points. 15 points of math points. You don't want to be missing one, right? For counting. This is simply for counting. Does everyone follow? Okay? Ready? Here. Left side, right side. How many sig figs? Number may look ridiculous, but you don't care about looks. Okay? What about this one? How many sig figs? Yeah. Now the one you can watch for an exam will look like this. I love to put this one on somewhere. Someone's going to run that one. I love this one. Over half of you are going to say this number of sig figs is 1. Guaranteed. And I just told you about it. 4. That's exactly right. It's 4, right? Does everyone see why it's 4? You strike here. Everything else is significant, including those zeros. This one, and this one are my favorites to see who's been listening. And they show up somewhere. Okay? Even if it's in scientific notation, you don't care about the times 10 to the minus 4. You only care about this. So this is a decimal, so it's 2. There's a decimal, so there's 3. Here there's a decimal, so there's 4. There's a decimal, so there's 7. This number drives students nuts. Okay, because they want to take these. Well, since you have this here and it's behind the decimal point, shouldn't we take these 2 off? Maybe you should, but it'll be wrong. Get it? Everybody follow us. I'm trying to point out the errors so you don't make them. 5 sig figs here. Get ready to make a note to yourself. Ready? This note is going to be on scientific notation. It will come back later on in the slides. But let's mention it here. Let's talk about it here so you have it. When you write scientific notation, rule number 1. write the sig figs first. You must write all sig figs. When it comes to scientific notation, you must ID and count the sig figs first. You cannot do scientific notation without knowing sig figs. So everyone follow that. You do not create a new set of rules when it comes to scientific notation for doing sig figs. It is still the exact same rules. Count the sig figs first. All of your sig figs must show up in the scientific notation. But that is not related to the times 10 to the minus 4 or to the exponent. The exponent only tells you how large that number was. If that exponent number is positive, it's a large number. If that exponent is negative, it's a small number. So everyone follows. If the number you start with is 0 point something, that's going to be a negative. This is your lesson on scientific notation. This is all you're going to get. Okay, because I'm going to assume you can do the rest. If that number starts on the left, is larger than the decimal point, then it's going to be times 10 to the positive. So everyone follows. So be aware of that. Now ready for big rule number 2. So rule number 1 is must be the scientific, must count sig figs. Rule number 2 for doing scientific notation. There is only one digit to the left of the decimal. It must always be one digit to the left of the decimal. Regardless of what it starts with, you can only, when you write scientific notation, there can only be one digit to the left of the decimal. That's it. Does anyone need me to write that on the board, or you got it? You guys get it when I say one digit to the left of the decimal? Right? Like 12.2 is wrong, right? 1.22 is correct. So everyone follow that. Only one digit. So you be aware of that for scientific notation. We'll repeat it again. So here are the answers to the one we just did. You know how to do that. Here we just summarize it down on a simple decision tree. You'll hear me say left-handed or right-handed for simplicity. It is mathematically sound. You're going to say this to some other professor somewhere in the world, and they'll say, oh, he showed you a YouTube trick. Well, it is on YouTube. I did post it on YouTube. It is out there. Oh, and yes, I did publish it at ACS. It is out there, but it is not a trick. It is mathematically sound, and I'm only presenting it to you to help you remember it faster. So everyone follows. And it helps me to say it and not have to go back to the rules. So everyone follows. I want to be real clear on that. Okay? This is not a YouTube trick. It's a mathematical process that allows you to count faster than having to memorize 12 rules. And you'll hear me summarize it as left-handed and right-handed. So everyone follows. In the decision tree, if it's left-handed, strike the front zeros, count. If it's right-handed, which means no decimal, strike the right ones and count. But you must maintain place value. This is critical. Everybody follow? If this number is 8,000 this, you cannot report it to me as 8101. Does everyone see that's not the same number? If you went to work and you made $810,000 and they paid you only 8,000, I don't think you'd be too happy. You must maintain the place value. Does everyone follow? It must be the same place value, 6-unit place value. Does everyone follow that? You simply ignore these for counting purposes only. So everyone have it. I want to emphasize that, okay? All right. So here, let's do an example to show you what we mean by the place value cannot change. When we need to maintain it, we add zeros. If you round and you need that place value, you add zeros, or you add a decimal point. We'll show you in these examples. Ready? Let's use this example. A golfer collected 2,147 golf balls over a 10-year period from various golf courses he played. Report this considering significant figures. Who the heck goes around and collects golf balls from a golf course? I don't know why he did it. Okay? That's just part of the conversation. Be careful getting distracted in word problems with the conversation. Got it? I give word problems. Don't get distracted by the storyline. So everyone follows. Okay? So he has 2,147 golf balls. If his original count is 2,147, that's it. If I round up to 3 sig figs, then I'm going to round to this part. So this rounds up. Does everyone see what I did? I put a 0 there. Anyone not see that yet? We're okay. Here, if I round to 2 sig figs, here I dropped it because I went from here. Okay. If you had given me this number, I'd have been happy. Just depends on where you start. Does everyone follow us? If I go to 1 sig fig, it's this. But if I put a decimal point back in there, down it goes back up to 4. Does everyone see that? Anyone not see that? Are we okay? In general, are you okay? Okay. You will need to know this. That's why I'm taking my time with it. This will cost you points. Not because you don't know how to do the math, but because you can't follow the sig figures rules. Now, someone likes to ask, why is that so doggone important? Why are you so anal on it? Number one is I'm just built that way. Number two, let's use a scenario. Ready? When it comes to rounding and sig figs. Let's say my grandma's in the hospital. Okay? And the doctor asked the nurse to dispense the meds to 3 sig figs. Her idea is 3 sig figs didn't quite work out. Okay? And give mom a bit too much med. Mom dies. They call me and they tell me that my grandma died. I'm going to say, bless you, grandma. You live a long life. I love you. I'll meet you in heaven. God bless, etc., etc. See you at the funeral. Gather with all the family. It's just life. But let's say you did that to my dog. Okay? You miss on sig figs with my dog. I'm just letting you know in advance. I'm coming after you. You got it? Me, every lawyer I can find, every friend. Okay? We're coming. You miss on sig figs with my dog? You call me and say my dog died? Are you nuts? I'm coming after you. It is that important. So now you understand why I'm anal about this thing. I'm protecting my dog. But those are the unfortunate tragedies that do happen because someone misunvalues. You got it? You don't want to miss them, folks. But I'm serious about my dog. Any other dog lovers in here? Anybody got a dog? So you know what I'm talking about, right? Seriously. When you got it's nuts when you have a dog, okay? If they call me right now, my kids, they're all adults, say, Dad, I'm in trouble. I'll see you tomorrow. Because say, your dog ran away. I'm gone. I'm out of here. Okay? All right, enough of that. But my point is, we have to take it a little bit serious to learn the process because we don't know where we'll be applying it. Got it? So that's why. Let's talk about how we do the multiplication with it. There are 2 sets of rules. There's multiplication and division, and then there's addition and subtraction. The rules are not applied the same way to them. Quite simply, this, when it comes to multiplication and division, you count the sig figs and the numbers you're doing, and whichever is the least, that's the boss, you round to that. If the smallest sig figs and the numbers you're using is 2, then you round to 2. If the smallest is 3, you round to 3. If the smallest is 4, you round to 4. So everyone follow. That's all you do when it comes to multiplication. Now, here's what we'd like for you to do. When you run your numbers, write your calculator number. Just run it out to a bunch of numbers. How many numbers is enough on your paper? So I'd like to see those when you report in your homework and in your exams. I call it calculator value. That number is there in case you make a mistake and for whatever reason my football team won and I'm in a good mood. Okay? And I look at it and say, okay, you just forgot the rule. You might get your points. Does everyone follow us? That's your calculator value. So I highly advise run the numbers first, write that calculator value out, and then round. Okay? To the proper number of sig figs. Let's take the examples here. In this particular case, we have 1 times 21. Calculator said 21. If I say round to 1 sig fig, because of this number, then it's 20. Does everyone follow us? Does everyone see how I just did that? This particular case, 1.0 times 21. How many sig figs in this first number? Somebody spit it out. Thank you. Decimal, nothing, right? Decimal, so nothing to strike. 2, thanks. 21.0 rounded to what? 21. Does everyone follow? The app, by the way, doesn't like zeros at the end of anything, so I hopefully account for that when I do the hand grade. I always do a hand grade look at it, okay? 1.53 times this number, this is a calculator, and we round to 3 sig figs. Why? Because there's 3 sig figs in this. Does everyone see that? No? Someone would have said 2 because they said, well, these zeros aren't significant. Are they or not? If I hear you say that, it means you're following the old rules. You do the strike in the front. Get it? So these are good zeros. So we round to 3 here. How many sig figs in this first number? Spit it out, somebody. Brace. How many? 4. How many in the second number? How many? What did we say? I couldn't hear. 4. Okay, thanks. Thank you. Just hard of hearing, that's all. 12.24, we're good there. Here, you already see the answer. But anyway, how many in this number? 2. So strike here, 2. So the answer should be in 2. We're good, are we? Not? But see, the place value is still there. Same thing here. We run them through. So this is what you'll have to do. And you have to do this over and over again the rest of the semester. You will have to be good at sig figs and rounding the rest of the semester. Okay? There are some places on the exams where the windows are very tight, that if you miss this, you miss the rounding, you miss the whole problem. Get it? It's that tight. You got it? And there are some where it's a lot more slop in it, because I recognize that sometimes we get these slight variations. Okay? Ready? One other thing okay, let's tell you about this now. There's also this thing called exact numbers. You'll see it a little bit later as well. That's counting numbers. For example, if we had to deal with the number of people it takes to load a truck, it's not 2.3, right? If it takes 2.3, you need 3 people. Does everyone follow us? Those are just counting numbers. How many students in the room is not 12.7? It's either 12 or it's 13. Which one is it, bud? You get it? Those are counting numbers, okay? How many carts are in the supermarket? Those are counting numbers, not an average. It's not a partial cart in the supermarket. You must differentiate between what's called exact numbers, which I call counting numbers, and when you use significant figures and things of that nature, okay? And in general, you'll know it as you go along the process. But if it's something you generally count that you don't have a partial of, that it doesn't make any mathematical sense to do that unless it's doing statistics, then it's going to be a whole count. So make sure you read the word problems correctly. And I have at least one problem like that on the exam where you will have to figure that out. You'll have to figure, should I report a counting number or do I report a sig figs number? You get it? So everyone follows. So just like to make you aware of that. By the way, when you attend lectures, I'll tell you what's going to be on exams. Generally, I do. I'll tell you what's going to be there. So if I say it's there, it's there. Okay? Okay? Except occasionally I'll forget something that's on there. Ready for addition subtraction. For addition subtraction, do not count the sig figs first. Only for the addition subtraction. Do not count the sig figs first. Don't do it first, because you will make a wrong assignment. Only count sig figs in addition or subtraction after the operation is completed. Most of these operations you can do in your head, but you have to complete the operation first. I'll show you before we leave a faster way to do it, but I'm going to show you the proper way first. Here, we align the decimals. That's how you do it. You align the decimals, and then you draw a line on the outside of the shortest decimal, and that's where you round everything to. Everything on the right side of that line gets thrown away or rounded up, okay? Follow the rounding rules. Okay? That's what we show you here. We line them up. Someone on yesterday's lecture asked me, they said, what about the zeros in front? I said, what zero? But if I put the zeros there, should I consider them as significant or not? Why the heck do you put them there? The first question. But if we follow rules, even if you put them there, are they significant? You get it? Because it's a decimal. Decimal says everything in front of that is insignificant. Does everyone follow us? If you need them to line up your math, great, but they're still insignificant. Does everyone get it? Okay? And at the end, then tell how many are in the answer. Only at the end. Do not tell it here, here, here. Even if it coincidentally is there, you'll blow your problem. You got it? You only tell for addition and subtraction after you've done the math. Okay? All right? Once you finish the math, does everyone get it? Okay? Here we show you some practice. Now, I'm going to show you how to observe this and know what your answer is going to look like before you get there. Same way when you do the multiplication and division, you'll know what your answer should look like simply by counting. For example, let's go back here. In this particular answer here, as soon as I see this 1.2 times this, I know my answer is going to be the 2 sig figs. As soon as I see this, I know my answer better be the 3 sig figs. I'm making that decision as soon as I write my given. I'm going to show you how to write your given to tell you your sig figs answers. Okay? There are several ways to do the math when you just do math. If you're a mathematician, I apologize to you in advance because you're going to hate me because I'm going to be forcing you to rethink the way you do your math and chemistry. Your answers are probably going to be right, and you probably absolutely can mathematically do it that way, but I'm going to be showing you a way to help you also determine sig figs early in the process. Does everyone follow us? It's not that your math is wrong. Does everyone follow me? It's not that your math won't work. That's not what we're trying to tell you here. Does everyone follow us? It's trying to help you through a process knowing where I have to take you later. Okay? And if you don't get this by chapter 3, be good to have it before then, but chapter 4 will kill you if you don't have this down. Okay? So here, watch this for addition and subtraction. As soon as I see this number, I know I'm going to stop my sig figs right there because there's no decimal in it. Does everyone see that? Whatever answer I write, it better not have a decimal. Because this is the degree of precision and accuracy here, is to this. You get it? It can't be more precise than the least precise one. Does everyone follow us? As soon as I see this next one here, I know it's going to be stop at 2 decimals. Does everyone see that? I go here, it's going to stop it. I can't count them. Whatever, I think this one must be the shortest. I think I'm going to stop here. And here it's going to stop here at 2 decimals. Does everyone see what I mean? Line them up, shortest decimals wins. Then count. These are just all rules, and it takes us time to go through them. Okay? You'll start to have chemistry fun starting next week. When we have to use exact numbers to do averages, don't count that number on the bottom. Ready for the next thing? So this would not be 7. You don't round up to 7 here, okay? This is taking an average. By the way, these data, if I told you the target was 6.7, what would you tell me about this data? Would you accept this data? What do you say? Accurate, precise? Any data in here bothers you? What about this one? You like that number? You like this number? You like this number? Hard to say, isn't it? I'd probably take it. That's not bad. You follow? So everyone get what I'm saying? So I'd probably say this is close enough to accurate if I take the composite of these. And if I take the average out, you can see it even better, can I? See how far it didn't bring the average down that much? Has everyone got it? Follow me? You're going to do problems like that. So they're reasonably reproducible here. If you did this 100 more times, this number here would probably not be that low or something. But that's not bad. Okay. So these are the rules re-summarized. Won't go through them again. Scientific notation, we've told you what's the rule for scientific notation. Number 1, sig figs. Number 2, only 1 decimal to the left. Then you're going to move your lines over until you hit the times. If it's a large number, it's going to be a positive. If it's a small number, it's going to be a negative. We're okay there? I assume you guys have seen scientific notation somewhere in your mathematical lives and careers. If you're struggling with it, take a look at this slide. It's just going to do this again. Take a break. Open your app too while we're gonna take a breather, take a stretch. Okay. Open your app to the discussion for today's pop quiz. It's the same as last week's. It's like one per chapter. So in your phone, your whatever device you have there. I'm going to write questions on the board that you could put in there, okay, while you're stretching, all right? And remember, you can always work with friends on this talk. You can now take a breather, stretch a minute or two. Can you see over here to this side? Okay, thanks. All right, we're going to do a couple of problems here. Punch those in your app. There's 3 problems to do, 4 problems. You sure you're okay? Should I do something differently for you guys over there? Can you see it now, maybe? All right, sorry about that. If you want to stand up and just come see it, that's fine. If you want me to rewrite it, I will. You good? Okay. And take a stretch. You can talk to friends, work through it together. No big deal. All right? You got questions while you're doing it, ask me. I'll tell you something. Go into discussions. It's whatever it's going to say, go into discussions, and it's going to say pop quiz, lecture 1 or something like that. Or ask some of your neighbors, they might know where to find it better than I do.
Same one that we did.
Yeah, same one.
Okay.
Yep, same one you did the other day. So and we'll get used to all of this, right? So you'll do one and do the same one for that chapter. You'll do the same one for that chapter, okay? And if you like to write it and screenshot it, shoot it with your phone. I don't care how you record it. Okay? There's no preferred format. It's under discussion. I'm sorry. So it's a discussion. Go down to pop quiz of number 1, chapter 1. Yes, that one. Click that one. And yeah, so this will probably be, just go in there somewhere. Yeah. How are you doing? Everybody good? Still playing with it? Any questions? Phone a friend? And by the way, I'm serious about my dog. Okay, just so you know, that's not a joke. So how many sig figs and what's the solution? Meaning the answer. And you can write on paper and take a shot of it or type it in there, any way you want to put it in there. Don't worry too much about over formatting and that kind of thing. Sometimes it's kind of off with the working canvas. Just for kicks and grins, it's a good idea to get in a habit of writing your calculator answer down too. You don't have to do it in this today, but it's a good habit to get into. It saves you. And I've had that happen to a couple of students. They had the right answer for whatever reason. They had a brain fart on the last one. Is that okay to say brain fart? I guess. Okay, brain freeze.
I was just added into this class yesterday, so
Yeah.
isn't the Canvas page isn't up yet? Is that gonna be a problem with this discussion?
No.
No, okay.
No. Just remind me, send me an email. After your canvas gets up and going, just send me an email reminding me that you just got added.
Okay, sounds good, thank
Yep.
you.
Yep, and then once you get added, you'll want to go to resources. Everything you need to catch up is already there.
Okay.
Lecture, videos, previous lectures,
Okay.
etc. All there, yep. Let's take a look, see what you get. And you have two sig. What you find, write your answer to the same. For it, yeah, for you find it. Okay, so that's your calculator answer. So your final answer should only have 2 digits in it. So your answer should be 2.3. You get it? So that's your calculator. You see what I mean? That's it. No, back on. So you only have 2 sig figs. That's correct. You only want to show those 2 in your final answer. Get it? The other one's what's in your calculator. You kind of write that down so we're going to hold on to it in case you make a mistake. So like the next one you only have, so this, no, okay, take a look at it. Or you're thinking behind the decimal point. You start counting sig figs, complete all the digits, not after the decimal. So how many sig figs are in this first, is going to be in this first answer? How many sig figs in the first number? 1. So your final answer only have 1 digit, not 1 digit after decimal point. One of the things that happens, I've seen this several times, is some reason students start to count sig figs after the decimal point. Did I say that anywhere in my rule? Did anyone hear me say count after the decimal? You count all the digits, regardless of where they're located. You get it? And I've seen that happen. About 33% of students do that. I keep these stats for some weird reason. Okay, so I'm trying to improve. Okay, my numbers are still running 33%. Okay, I already understand 33% of students do that. Make that same mistake. It's the total. So if it's one sig fig, it's right. It's going to be some ridiculous looking numbers here. And I'm doing it on purpose. I'm forcing you to learn the rule. Yeah.
Alright, so do you want us to get the sig before or after the calculation?
It doesn't matter. It's going to be the same answer. The number of sig figs will never change. You know, you can know that beforehand. You get it? And when you report your answer, it should only be one. Yeah. No. In terms of addition and subtraction, you cut it off. And wherever it cuts off, then you just leave it. Four sig figs. Correct. Wherever it cuts off, you just leave it. That's why I want to do this with us. Yeah. Wherever you cut it off, you just leave it. These are just rules. Does everyone follow me? We're introducing the rules today. No, we only do. Because the first once you have, well, you final answer. Your final answer is what you care about. Your final answer, say, you round off your final answer after calculating. Yeah. Number 3. What you add it together. That's going to cut up. Number 3 is going to be, is that a 12? 12.17. Your answer for number 3 should be 12.18. That should be your final answer. No, I'm sorry, I missed one. Missed a digit. That's a 9 up. That should be a 9 up. 2.9. Whew, I can't add.
Yeah.
Did I warn you guys that I wear bifocal contact with a stigma? Yeah, that's a warning, right? I'm not the guy you want reading these numbers. Okay.
Yeah, so I just ran it to 3 because.
No.
Or just
You count everything that's left. It doesn't matter whether it's before or after decimal. But the decimal rule just tells you where to start eliminating things. So on like what's that number? On number 2, that's a left-handed strike, right?
Yeah.
So we count 2 digits left, 2 sig figs. You don't start counting after the decimal. The decimal just tells you which rule to use. The decimal only tells you which rule to use. So everyone follows. Got it? When you see a decimal, you say I use this rule. When it's not a decimal, go ahead. Two point three, that's correct.
Oh, okay, yeah. Well, because then those
What's your answer?
because these are still considered 0 and 0, so there's only one sig there's 2 sig
Right. But 0, 2.
So then I just moved
Yeah,
it.
that's correct. That's how you got the
So you
rule.
just drop them.
Some of these are pushing the limit of the rule to see if you can catch it. Yeah, what you got? Yes. When you're ready. Add them together. Show them what you got. Did you take any numbers out before you add? Leave all of them in your first add. Oh, you moved the most. You moved the most.
So what I just did was just added it on my computer just to make sure.
You don't change anything. You do regular arithmetic. Let me make you aware of something. This is important. You do not change your regular arithmetic in any of this. The rules are here to tell you how to report your regular arithmetic. Do not make up any new arithmetic. Everyone follows. The same old first grade arithmetic rules follow. Everyone follows? It's just telling us how to report it. That's the only thing these do. They don't change any mathematical processes. They just tell us how to report it. Everyone follows? For example, 0.123 does not get changed to a new number. It is 0.123. It's not 123.0. Zero follows. That's important. That's why we do this, by the way.
So it's 0.123. That's what a lot of times.
Oh, you can see. You may have the same thing I had. You're looking at the number and saying, what the heck? Yeah. If you don't, and that can happen to you. By the way, sometimes you make an honest mistake by just not reading a number. I can deal with that. But that's just real life. Yeah. You got one that I'm gonna move on here just a minute. Okay, everyone kind of get the idea? I need to frustrate you a little bit today so you get ready for it. That's 2 CP.
For which one?
What's your answer? You for the answer to only 2 CP. Cut it off to 2 CP. No, that's 2 CP. The answer is solution.
For, you're talking about boy. So,
It's not. Don't try to say solution is wrong. The answer should be what? How many CPs should be in your answer? 2. So I can only see 2 digits there. Not a 0. Why 0? What did you have that before? Retype it what you had before.
10.1.
3 something.
Because
3.
3 is significant because it's between two significant.
Whatever that full number is, you got to round that number off.
Yeah, but this is just the calculator solution. Significant is sorry.
Round it to 2 CPs.
I think that
Three.
he's asking us for sick things.
No, because that adds 2 CP. You see what I mean? Okay. You tell me, where did you cut it off at? Why did you cut it off there? What's the deciding factor where you cut it off at? Did you line up the decimal points? That might help. The decimal points line up into the shortest decimal point. Everyone follow. There's no equation to figure out. You're just doing that to it. Don't complicate it. Just give me the answer.
Is this kind of
There's no equation, there's nothing. There's no deep math in any of this. All right, we're gonna have to stop here. Yeah, go ahead. What's your question?
I was just gonna ask you, can you look at
Your second one there. Let's see. Solution is 0.1. That's what you got. You're up to 3 CPs. I don't see but 2 CPs in your answer. How many you see in your answer?
So,
What's the rule say? Decimal. Right, left. Count. 2 left. And you told me the answer should be 3
I
CPs.
don't know what you said, but like.
I'm just going on what you're telling me about it should be. You're telling me it should be 3? Why'd you say it should be 3, by the way?
So
What did
technically,
you
this
calculate?
fourth 0 there.
What's this?
The fourth digit.
How many CPs should you have in your answer?
So, and obviously you can't.
Okay, I know what's happening to some of you guys. You think I'm asking you how many sig figs are in your calculator. I don't give a rip. I want to know how many sig figs you're going to report to me. Your calculator is going to give you 29 numbers. Got it? I don't care about those. You take that number, then round it to the proper count. The proper count is based on what you start with. Got to move on. Got it? Come to recitation. Okay? So here, how many sig figs should be in your final answer? So if you report a number to me with more than 2 in it, you're wrong. I'm not going to grade this, by the way. This is just practice. So I'm not panic. Oh, I just missed points. No, you participated. That's good enough for me. You got it? This session is not graded. Does everyone follow me? This is to help us all get together. And don't let the loudness of my voice bother you, okay? I'm just loud. Okay? So, that number punched through is 2.323. So you round that off to 2.3. That's 2. You get it? This number, what do we get here? I don't know what it comes out of these. Is 0.161? How many sig figs should be in that answer? So its answer should be what? 0.2. Everyone follow us? This one, that added up to some weird number like 29. So you're going to go to your second place. You're not going to count first. You're going to go to your second place. Does everyone follow that? You line these decimals up, and this is going to be the shortest to this second place. And that's going to be a 29. I'm sorry? Because of what? You still confused for that? Are you counting before you do it? That's why you're making a mistake. You don't count before you do it. That's the point I made earlier. Do not count in addition or subtraction before you do the math. That's the rule. Does everyone follow me? The rules are solid, but you have to follow them. Remember I told you don't mix them? If you follow them, they work. we have to interpret them too. This one, round off to 3 sig figs would be 10.1. We agree? Round to 4 sig figs would be 17.10. The app won't take the 0, but the discussion part will take the 0. So, okay, got to move on. All right? See your recitation for those that are still struggling. You won't want to get this down. Okay? You'll blow your problem. All right? And for those of you who are frustrated and pissed, when you finally figure out that we're right, you'll feel better. So drop the frustration and pissed at the professor, because this is what you're going to see. It only clogs your brain chemistry. You get it? Your brain can't deal with pissed off and learning at the same time. Get pissed off later on tonight. Got it? Ready? Here we go. We're going to be doing our math by a process we call unit dimensional analysis. Make sure you watch my videos on this. I just posted them last night. Watch the videos, then watch them again, then watch them again. They will walk you through this over and over again. In the practice, there's a practice on this. You will want to do it. The standard, this is the standard. The best way to do unit analysis is to identify your best given first. Make a note. When given a choice, your best, I'm going to tell you what's a not. Your best given is not the one that has a per sign in it. If your first mathematical operation has a line under it, and that line is not a 1, don't take that. You'll see what I mean. Your best given is the one that's non-compounded. When you read the problem through and watch one of my videos, I comment on that. I just posted it for you in the announcement section. Can you do it the other way, mathematician? Yes, you can, but occasionally you'll have to flip. And since I'm familiar with the mathematician trying it that way, I create at least one problem where it frustrates the heck out of the mathematician because they get to the end and realize, oh, shoot, I should have flipped it. And then they look at the clock and they run out of time. Okay? Your best given should not be a compounded unit. It should only be a single unit. It should not be that. Here's something to make a big note of. Mile per hour, MPH is not a unit. Let me say it to you again. MPH is not a unit. If you write MPH on your paper, you just lost 2 points. That is not a unit. That means miles divided by hours. That is a unit. MPH is not a unit. Does everyone follows? But if you use miles per hour, it must say miles divided by hour. So everyone follows. But to say MPH on your paper, you just lost it. So here's a thing, trick, or system for doing unit analysis. And you'll watch the videos on this. Be sure you watch them. They're posted out there. They give you something to do over your break. Okay? If you write the first unit, whatever that is, that's your key. This first unit will oftentimes define the sig figs, because whatever you start with here, better end up out here. It will also give you your initial unit that tells you what your second down unit is going to be every time. If this is inches, then your second unit down here is going to be inches. This is gram, this unit is going to be gram. If this is zebras, then this is going to be zebras. You get it? That is the key to starting a good dimensional analysis. If you start there, usually the rest will work its way out. In recitation, if you choose to do some of your homework today, we'll talk you through it as you're doing it. Okay? But it involves a given, a conversion factor, a result. This result must be a sig figs answer. Conversion factors never, that's an NEVER, count sig figs here. Never. You do not use conversion factors to count sig figs. Do not use conversion factors to count sig figs. 1 inch equals 2.54 centimeters. I don't care about the sig figs in that. So everyone follows. These are the rules for this. Let's show you how it works. Watch how I do it here. Ready? Convert 34 inches to centimeters. Note that 1 inch equals 2.54 centimeters. I'll always give you those conversion factors. You won't have to sweat over. What you will have to sweat over is using this process properly. Ready? So my given is 34 inches, not 2.54 inch per centimeter. This is a conversion factor. I do not start with it. unless the problem is for converting conversion factors to other conversion factors. You get it? Which I rarely give you. So everyone follows. I rarely give you convert this conversion factor to the other. I have some practice problems though and some play props in the other practice. They're there for you. Keep your mind fresh. So here we go. I write my given. As soon as I write this math process down, automatically, do not second guess it. If inches are here, it goes down here. Here now I look for my relationship. My relationship is inch and centimeter. Does everyone see that? It's a known relationship. Can't make it up. Now, here's what bothers students. They say, should I put the centimeters on the top, 2.54 on the top, or should I put the 1 inch on the bottom? Wherever, take a look at this. To what unit is 1 inch attached? It's attached to this unit. Does everyone see it? To what unit is 2.54 attached? It's attached to this unit. Does everyone see that? This is a quick math review. So everywhere 2.54 goes, what should go with it? Centimeters. You get it? You should never separate 2.54 from cm. So never, I don't care what anybody in the math center tells you, okay? What the mathematical genius tells you or grandma tells you. This should be like this always, not this. Someone said, well, I solved it that way. You solved it that way, but it was the wrong units. You get it? That's wrong. Does everyone follow us? That's a math thing for you. What I'm telling you now is not science. I'm telling you math. Okay? We go here, we punch the answer through, 2 sig figs, 2 sig figs. Let's do the next one. This number of pounds to grams, I'll give you this. It'll be on a table, or I'll tell it to you. My given is this. I write my given first. I do not write this because this is a ratio. I do not write ratios first as often as I can, unless that's my only last resort. And it's rare in my problems that will be your last resort. I write the number, math process down, relationship up. Math process down, relationship up. I can find this in the problem, can I? And notice the grams are with the grams, and the pounds are with the pounds. I do not separate those. I do not call it 1 and 453. That's wrong. Does everyone follow why that's wrong? Because it doesn't have the units with it. It's gram goes there, pound goes there, same units. And remember, MPH is not a unit. Let's do another one. A person's average daily intake of glucose is for that number of pounds is that. What's the mass in milligrams? I gave you all the table. I will always give you a table. We write the pounds, math process down, relationship up, math process down, relationship up. Answer is out. The first unit, my best given, carries the sig figs with it, 3 to 3. Do not, absolutely do not use conversion factors for determining sig figs. That's the process. There are 2 formulas that you will be allowed to use. You are allowed to use the density formula except in doing a unit conversion. If I ask you for density, you simply use a formula. I repeat, if I ask you for density, you simply use a formula. Otherwise, you will use dimensional analysis as a process in this class. That's a process I just show you. Watch the videos. They take you through it painstakingly over and over again. Okay? If you need math help, go to the math center. They'll walk it through. Take my slides with you so they don't create any new math for you. Okay? Say, this is what he's doing. Show me how to do it. Okay? So density equals mass over volume. If you know the mass, you know the volume, you get it. Here, we conveniently gave you 3 sig figs, 3 sig figs, we get the answer. This is plug and move. You get it? Put it in the formula. Nothing is special, but the units must follow. Centimeter cube is the same as ml. You will be learning that. In my calculator, I had 19.29 bunch of numbers. I rounded up because 3 sig figs. My battery is slow and I did that again. Okay, gotta finish this. Hold on. I'm out of time, aren't I? All right, in your slides, there's only one other thing in the slides. There's a formula for converting temperature. Use that formula. That was the next slide that we just lost. In the slides, there is a formula for temperature. Use that formula for doing temperature. Anytime you have to go from to Kelvin, K as the temperature, you must go through C. You can never get to K without C. Make a note of that. I cannot get to K without C. I cannot get to K without C. Got it? That was the last slide in there. See your recitation for those of you who are coming. The expectation is that you can watch the videos. There's nothing in the videos that's going to be new. That's your lecture for it. You finished chapter 1, folks. This is the pace. And I publish videos as supplement to keep you on track. Don't forget, be the hit of your next party this Friday. Pull out your cell phone and work some chemistry problems. There you go. You'll be a hit at that party. Nobody will ever forget you.